In this video, you are going to learn about dynamic memory handling in C and C++. So why wait? Let's get started. This is Sai Sumant and welcome to Skills Grow. Dynamic memory in C language. In C, dynamic memory is allocated from the heap using some standard library functions. The two dynamic memory functions are allocation function and free function. Allocation function. The allocation function takes a single parameter, which is the size of the requested memory area in bytes. It returns a pointer to the allocated memory. If the allocation of memory fails, it returns null. The prototype of the function is as follows. And the free function. The free function takes the pointer returned by the allocation and deallocates the memory. No indication of success or failure is returned. The function prototype is as follows. Let's learn about the memory allocation in C++. Dynamic memory allocation in C++ refers to performing memory allocation manually by programmer. New and delete operators are used for dynamic memory allocation in C++. Stack. Memory from the stack is used by all the members which are declared inside the function. Heap. This memory is unused and can be used to dynamically allocate the memory at runtime. When we dynamically allocate some memory to a variable, we actually use the heap memory. But how is memory allocated or deallocated in C++? The new operator. The new operator requests for memory allocation on the heap. If the sufficient memory is available, the new operator initializes the memory and returns the address of the newly allocated and initialized memory to the pointer variable. Syntax for new operator. To allocate memory of any data type, the syntax is: here, pointer variable is the pointer of type data type. Data type could be any built-in data type including array or user-defined data type. For example, the pointer is initialized with null. Then request memory for the variable. The combined declaration of pointer and their assignment would be: we have seen the declaration. Let's have a look at initializing the memory. We can initialize the memory using new operator. For example, here we have initialized the integer type memory and the float type memory. But what if enough memory is not available during runtime? If enough memory is not available in the heap to locate, the new request indicates failure by throwing an exception of type standard bad allocation, and new operator returns a pointer. It may be a good idea to check for the pointer variable produced by the new before using it in the program. For example, when we allocate memory using new, we can show warning by using a condition that memory allocation failed. It is the programmer's responsibility to deallocate dynamically allocated memory. Delete operator deallocates the memory which is allocated by the new operator. We can use deallocated memory for further allocation. Here is the syntax. Here, pointer variable is the pointer that points to the data object created by the new. For example, to free the dynamically allocated array pointed by the pointer variable, use the following form of delete. It releases the block of memory pointed by the pointer variable. Dynamic memory allocation for arrays. Consider you want to allocate memory for an array of characters, that is, string of 10 characters. Using the same syntax what we have used above, we can allocate memory dynamically as shown here. Firstly, the pointer initialized with null and then requests memory for the variable. To remove the array that we have just created, the statement would be: this deletes the array pointed by p-value. Following the similar syntax of new operator, we can allocate a multidimensional array as follows. Here, the pointer is initialized with a null and allocates the memory for a 3x4 array. However, the syntax to the memory allocation for multidimensional array will still remain as above. What are the uses of dynamic memory allocation? One use of dynamic memory allocation is to allocate memory of variable size, which is not possible with compiler allocated memory, except variable length arrays. The most important use is flexibility. And also we are free to allocate and deallocate memory whenever we need and whenever we don't need. There are many cases where this flexibility helps. Examples for such cases are like linked list, tree, and etc. This is the basic introduction to dynamic memory handling in C and C++. Thank you for watching the video and stay tuned for more content from us.